All right, we're going to go ahead and get started on our notes covering surface area. So throughout this chapter, we're going to be doing surface area of many different 3D shapes, but today we're going to focus primarily on rectangular prisms and cubes. So surface area is essentially, I'd say the simplest definition would be the area of a 3D object. So we've spent a lot of time this chapter learning about finding the area of various shapes, and those shapes have all been 2D shapes. But now we're going to be jumping into surface area, which would be like the area around the outside of a 3D shape. So picture you're maybe wrapping a Christmas present, and the surface area would be like all the sides that you need to cover with wrapping paper around that 3D shape that you are wrapping. There are many different ways that you can find surface area. Some teachers, when they're teaching about surface area, they teach students to use nets to find the surface area of the shape. I actually personally don't prefer this method. I think that with nets, you end up having to like redraw and relabel different pieces, and I think that that leaves a lot of room for error. So I do not teach students to use nets. You're welcome. If somebody has taught you that in the past, you're welcome to do it. I'm a-okay with it. It's a fine way of finding it. I just think it leaves more room for error. And so I actually choose to approach it slightly differently to try and avoid that. So what I'm actually going to have you do right now is actually turn to page 2 in your notes. So this first page right here about surface area, we are actually going to skip over the practice problems there, and we're going to jump to these ones on the back here. So go ahead and get flipped to this page. And I do want to showcase for you guys just through this GeoGebra here. So when we are finding the surface area of a shape, so right here I have on my screen, this is a prism, a rectangular prism. When we are finding the surface area, essentially we're finding the area of those 4 green rectangles, the 2 blue squares, and we're adding them all together. So it's perfectly fine to lay that 3D shape down into a net and find the area of each of those nets and add them all together. What I prefer to do though, is I prefer to find the area of just the top of the shape. So like that blue square up there, find the area of it. And then I like to times it by 2 because there's a top and a bottom, right? There's that top blue square and then there's the bottom blue square. And then I like to find the area of the front of this shape. And then I like to times it by 2 because if we have a front, we also have a back. And then I like to find the area of one of our sides here. So like this right side or this front side that we're seeing. And then I like to times it by 2 because we have that back piece that's being pulled down as well. And so I simply find each of those areas and I double them, and that gives us the front and the back, the top and the bottom, and the left side and the right side. So let's take a look at example 5 here in our notes. And using example 5, we are going to do just that. This is a rectangular prism here. And so in order to organize my work, I'm going to go ahead and I'm going to put an F/B, and that stands for front/back. So we are only going to be looking at the front of my rectangular prism here. So I'm going to go ahead and highlight that in purple. And the front is a square, so to find its area, we will multiply 6 times 6, and that gives us 36. And then we have to remember that we're going to have a front and we're going to have a back square that are congruent to each other. So when we times by 2 right here, that gives us the area of both the front and the back. So I've got 2 of the total 6 sides that I need. Next up, I am going to go ahead and write a T/B. That stands for top and bottom. So we're going to be looking at the top and the bottom of this figure. I'm going to go ahead and highlight those in orange. So there's my bottom right there. And looking just at my bottom, I can really easily see that I need to multiply 13 times 6 this time around. So for the front and the back, I multiplied 6 times 6. Now I'm going to multiply 13 times 6. And you guys are more than welcome to use a calculator this unit. So 13 times 6 is giving me 78. So 78 represents the area of only of the bottom of that shape. I want the top of that shape as well. So I'm going to take that 78 and I'm going to double it. So that way I get both the top and the bottom. And I am getting 156. And then last but not least, I'm also going to be looking at the left and the right side of my shape here. So I like to put L/R for left and right. You can see I've got that highlighted in blue. So for my left side right here, I can see that this shape is 13 yards wide. And then if I go straight up and down right here, it is 6 yards tall. So I have to multiply 13 times 6 again. And 13 times 6 gives us 78. That gives us the area of the left side, but if we want the area of the right side as well here, we are going to have to multiply by 2 again, which will give us 156 again. And one thing that I do want you guys to notice is that as we multiplied 6 times 6 here, I underlined the 6 and the 6. As we multiplied 13 times 6 here, I underlined the 13 and the 6. And then as we multiplied 13 and 6 again, I underlined the 13 and the 6 again. So as I used each of those numbers, I underlined them. And you'll see that now each of those have been underlined twice, which means that I did the problem correctly. I used each of those dimensions twice. And so our final step to find the total surface area, total tells us, let's just go ahead and add those all together. So I am getting 384 when I add those together. My label will be yards because that's the label from the picture. And area is always squared, so surface area will also be squared. All right, we're going to go ahead and jump down to number 6 now. And again, I'm going to get my work set up. I'm going to do my front and my back. I'm going to do my top and my bottom. And I am going to do my left side and my right side. So I'm just getting each of those written out so I don't accidentally forget any of them. And then in purple here, I'm going to go ahead, I'm going to highlight the front of my shape, and then I know that the back is congruent or equal to it. So for the front of my shape, I see that it is 10 centimeters, so I'm going to underline that once, times by. The height here, we're actually going to get from the back, it's actually 18, so I'm going to underline that once. When I multiply those two, I will get 180. And remember that 180, that's only the area of the front. If I want the area of the back as well, I have to double it to get 360. Next up, I'm going to take a look at the top and the bottom. So I'm just going to go ahead and highlight my bottom here in orange because I can see my dimensions are written down at the bottom here. So I'm going to be using these. And I can see that my bottom is 10 centimeters by 7 centimeters. So I will underline each of those once. So for that top, or the bottom, I suppose we were doing, we get 70. And then again, we got to remember there's both a top and a bottom. So we times by 2 to take that into account. And we get 140. Now, because we've been underlining, the left and the right side dimensions should be pretty easy for us. So I've got highlighted in blue the right side of my shape. I can tell that that is 18 centimeters tall and 7 centimeters wide, and those numbers each needed one more underline to get 2 under each of those. So I know that I'm correct in those dimensions. So we will multiply 18 by 7 to get 126. And remember, that's just the right side area. So we do have to multiply by 2 to get the left as well. And that is 252. So at the end, to get that total area, the word total tells us, let's go ahead and add those all together. And I am getting 752. My label here is centimeters, and we're working with area, so that will be squared. 752 square centimeters.